Midas NFX Lecture 6 Transient Dynamics Problem Direct Integration Method Impact Problems. Open the case. Give it a name. Import geometry. This is the end of first step, importing a 3D model and open the case. For step 2, we will load the material, an isotropic material, low carbon steel, 1020. And property is to connect the 3D model with the assigned material. So this is the end of step 2, assigning material to the geometry. Step 3 will be meshing. First of all, select the geometry and define the mesh size and perform the meshing. Step 4 will be boundary conditions. So in statics, we choose constraints and select face to be the entity and choose bottom surface to be totally fixed. And for the dynamic load, we'll choose dynamic, and here it is a transient force. We'll choose surface of the load, this surface, and then assign direction of the load, this x direction, and the magnitude of the load. So this is the surface of the load, direction of the load, and the magnitude of the load. And before we hit OK, we'll define a time function where at the time of 0 the force is 10 Newton. At the time of 0.05 the load is 10 Newton, and at time of 0.06 the load is 0. So it is a load that we impact at a 10 Newton force for about 1/20th of a second, 0.05 second, and then the force is released and let it free swing of the structure. So this is the time history of the force. So we defined a time-dependent force. For step 5, we'll include a transient dynamics problem. So it is in other. We give it a name and choose the proper direct transient response. There are two types of transient dynamics problem, and one is model superposition and the other is direct integration. So you might want to consult the manual or the theoretical manual to get a glimpse of what the time integration and model superposition methods, and I'll choose direct transient response. And for this direct transient response, we can assign a damping to the structure, but now I'm not going to do it. And it is very important that the solution will be time dependent, so I have to give it a time history. So the total solution time will be 1 second and will be divided into 100 steps, and I'll add the problem. So I'll let the software to calculate 100 steps for about 1 second, so each step will be 0.01 second. And now I can go ahead and calculate. And during the calculation, the software will display the maximum displacement of the structure. So you can see that the structure undulates, swings, or vibrates to and fro, left and right. So this is after the force is released. The structure vibrates on its own. and we can see the total deformation, and with animation we can see that the structure is undulating or vibrating from left to right after the force is released, because the force is released after 0.05 second, and after that the structure vibrates on its own. So now we'll get the numerical values. This is a probe of the numbers, the displacement numerical values, but we'll extract the time history. So first of all, we'll determine the displacement of a point. We'll assign this point, and the software will give you the number of the ID number of the node point here. So I'll let it create the numerical values on tables, and I'll mark all these numbers for 100 steps, and I'll give it a graphing and assign the step to be the x-axis and the displacement as the y-axis, and I get the result that at the top of the structure, a point at the top of the surface, and the structure vibrates or undulate to and fro. So this is the solution. So we can save the file and we can process the data in Excel and other softwares. So this is the first part of dynamics analysis, an impact problem performed by direct integration method of transient dynamics. And in next lecture, we are going to talk about another method, which is model superposition method for solving a dynamics problem. Actually, in the direct integration method, there are also two types. The one is explicit dynamics, and the other is implicit dynamics, and we will talk about that also later. So this is lecture 6 of Midas NFX.